The Pathe cinema is obliquely oriented to the north-south. This means the sun will rise in the east, and during the afternoon it will be facing the south facade of the building. The sun will set in the west. In wintertime the sun will be much lower. The wind will mainly be coming from the southwest. Concerning the construction, we had to take notice the building was erected on an existing parking garage, which means it has a lightweight structure. The cinema halls are constructed out of a steel construction. This is reinforced with tension cables. The rooms gain stability through a steel plate concrete floor, which has a stiff connection with the steel structure of the rooms. The facade and cinema rooms are structurally separate from each other. Both carry their own weight. Concerning the facade, this is structured out of two iron beams at the top and the bottom. Wooden pillars are used to carry the weight. Some wooden columns are replaced with iron ones for stability and strength purposes. The whole system is reinforced with tension cables to achieve stability. Whoops! I've drawn it a little bit too abstracted. This is more how the tension cables are positioned. The facade has two basic variations. The first is just two corrugated sheets separated with air to provide isolation. The second one, in front of the cinema rooms, has concrete behind the corrugated sheets and isolation behind them. Regarding the climate system, the building can basically be divided into two climate zones. The first are the red, highly climatized cinema rooms, and the second is the blue foyer, which is an in-between zone. The foyer is climatized and ventilated by means of an air conditioning unit, and to prevent draft, radiators are placed in front of the facades. In the cinema rooms, warm, climatized air is blown in below the seats and extracted through the ceiling. We've chosen to design a new facade for the eastern facade. In our view, there are four issues that need resolving, if possible, in a sustainable way. 1. Behind the east facade are two climate zones that highly differ, heavy climatized offices and the in-between zone of the foyer. The second problem is that the building overheats in summer. They resolved this problem with a new air conditioning unit, but in our view, there are better solutions. 3. The new facade has to be as lightweight as possible to be suitable to be built upon the existing garage. The fourth and the last problem is that there is a lack of visual connection between the square and the inside of the building, and we consider this a missed opportunity. In an ideal situation, we would like that on a summer's day the new facade provides shading and a better and sustainable way of cooling the building. At night, we would like the building to be better isolated. In both night and day situation, it would be nicest if the visual connection between indoor and outdoor is possible. In wintertime, this scheme doesn't change much. The biggest difference between the summer situation is that we would like the facade to let more sunlight in than in the summertime, and that it's better as isolated than in the summertime. In both situations, again, we would like a visual connection between the indoor and the outdoor. Our research question is how to sustainable control, in terms of a low energy consumption building, the indoor climate of the foyer with a dynamic facade that adapts to the different seasons and day conditions and still retains its transparency. Katharina researched different facades with inflatable membranes that could also provide shading and would meet the isolation purposes. In her first design, she used different layers of membranes to change the amount of isolation and also provide different amounts of shading. Andrea researched different climate system of box-in-a-box kind of buildings. She also looked into buffer zones in front of facades. Her first design was a kind of second skin facade that would function as a buffer zone. Marijn researched different kind of climate facades and louver systems to provide shading. His design was a combination of a louver system that, when closed, could function as a climate facade. Bowen researched the possibility of a facade that can completely open. A big folding door was used to completely open the facade and make foyer part of the outdoors.